Question 11. Part A, calculate the mass of oxygen required to react with 32 grams of methane. So we're going to be using this equation to help us. This is a reacting mass style question, so we can set up our little table to help us. So we're looking at CH4, methane, and oxygen. We can set up mass, MR, moles, ratio. So we know the mass of methane to be 32, and its MR is actually given to us here as 16. So just a reminder that moles is mass over MR. So we can see 32 divided by 16, which gives us 2 moles. Now we can then use the ratio between these two molecules to work out how many moles of oxygen 2 moles of methane will react with. So let's have a look at the equation. So we can see that we've got 1 mole of methane reacting with 2 moles of oxygen. So the ratio is 1 to 2. So therefore, if we've got 2 moles of methane, that will react with 4 moles of oxygen. So then we can work back up to work out the mass of oxygen that would be. So mass is moles times MR. The MR of an O2 molecule is 32. So we do 32 times 4, which gives us a mass of 128. So our answer is 128 grams. Moving on to B, so we've got this apparatus. To start with, focusing on this area, wants us to explain why some water collects in the U-tube. So in this area here, well, we can see we've got this U-tube sunk in a bucket of ice. So the water, which forms when methane burns, will travel through here as a gas or a vapor, and it will cool down and condense because the ice is cold, I suppose. So we've got gas condensing into a liquid. So the water will cool down and condense because the ice is cold and there's a big decrease in temperature. We can test for the presence of water using some anhydrous copper sulfate. So the anhydrous copper sulfate is white. Copper sulfate is white, but when it's in the presence of water, it will in fact turn blue. So that's how we use anhydrous copper sulfate to test for water. It's a color change from white to blue. Moving on to the next question. So quite a lot of detail required here. Explain the change in the appearance of lime water. So if we go back at our apparatus, we can see that once all the gases have traveled through the U-tube, it's bubbled into the lime water here. Just a reminder, so when we burn methane, which is a hydrocarbon, we produce, as we said before, H2O water, but also carbon dioxide. So if we're pumping carbon dioxide into lime water, that will turn the lime water cloudy. So the lime water will go cloudy in the presence of CO2. So that's actually 2 out of 3. We actually need to explain what that cloudy appearance is coming from. So what happens is we get a reaction between the carbon dioxide and the lime water, and it forms insoluble calcium carbonate. And that appears as a white solid or a white precipitate, and that is why the lime water goes cloudy.